going to do another reciprocal rule problem. This one is going to be a little bit more complicated, and we're actually going to use chain rule at the same time. How exciting! I'm going to go ahead and write out reciprocal rule just so that we have it in front of us. It is 1 over f of x equals negative f prime of x over f of x squared. All this is saying is that if you have a function with the 1 on the top and the function on the bottom, that the derivative of it is the following: the derivative on top, the function squared on the bottom, and a negative sign out in front. So the problem we're going to do is f of x equals 1 over x plus 1 over x squared. So we know we can apply reciprocal rule to this problem because we have a 1 on the top and we've got some function on the bottom. So we'll do this one step at a time. We will go ahead and say f prime of x, the derivative, equals, the first thing we need to do, we'll go ahead and say negative, because we know that we need the negative, and then the top and the bottom here. I'm going to go ahead and write out the bottom because we already know what it is. It's the bottom of this function squared. So we'll say x plus 1 over x squared is the bottom, but then we need to square it up here. So we add an extra set of brackets and square it again. So we basically leave it as is and square it for the bottom. So really all we have to do is deal with the top, and that's taking the derivative of the bottom right here. So to take the derivative of this is where chain rule is going to come in, and what we're going to do is apply chain rule. So we'll say 2 times x plus 1 over x. I took the exponent on the 2 and I brought it out in front right here to this position because we're treating everything inside the brackets here as one term, bringing the 2 out in front, multiplying the exponent by the coefficient, which is that implied 1 right there. So we get the 2 out in front, and then subtract 1 from the exponent. 2 minus 1 is 1, so that's a 1 right there, but of course it's implied, so we don't need to write it. So we use chain rule to do that, but then on top of it we have to multiply this whole function by the derivative of the inside of this part right here. So we need to take the derivative of the inside as a second step. So the derivative of the inside we'll do term by term. The derivative of x is 1, so let me go ahead and say we'll multiply here. The derivative of x is 1, and then plus the derivative of 1 over x is actually negative x over 2. And the way that we do that, I actually do it in my head. I bring the x, I take this term right here, and I convert this from 1 over x to x to the negative 1, because when you have something in the denominator, you can move it to the numerator and just flip the sign on the exponent from a positive to a negative. So I make this x to the negative 1 instead, and then I bring the negative 1 out to the front, so I say negative x, and then to the negative 2. Oh, sorry, see, I knew I needed to check myself. This is negative x to the negative 2. So then that ends up converting to negative 1 over x squared, because just as I moved this from the denominator to the numerator and flipped the exponent, I can move this x to the negative 2 now from the numerator to the denominator and flip the exponent from a negative to a positive. So I brought it from the bottom to the top, and now I'm bringing it from the top to the bottom, and I have to flip the sign on the exponent both times. So this ends up being negative 1 over x squared. So this will be negative 1 over x squared, and since we have plus and then a negative, we can just go ahead and make this minus. So now that we have multiplied, this by the derivative of the inside, the derivative of this section, we've taken the full derivative of this whole function. So we can, you could simplify this, but there's nothing glaringly unacceptable in this. So we can go ahead and put it up here and say 2 times x plus 1 over x, and then 1 minus 1 over x squared. And that is, that's the top. So this here is the derivative of the bottom, and this is the bottom squared. And then of course we have our negative sign out in front here. You can't forget that. That's the third component to the reciprocal rule. So there you have it. That's the answer. Thanks.